Hello. Hello, everybody. What's up? The deal for today is that Anton will be finishing up the large arrays of things, which is an unconventional way to store a state. In huge arrays with stable pointers, with using indices instead of pointers usually, but we're gonna get to it when he'll join. He might be running a little bit late, so we have some time for chit chat. Coding some Odin, nice. What are you programming? Let's get back to the off-grid cabin. What? Oh, last time Anton already compiled the thing, which was like a secret ending of the episode, which honestly, like, when I'm programming, like, it's obviously, if it's not that big, like, I can get it to compile like a larger chunk of things, but his ability to like code live and do things that are not that straightforward and then hop over there, compile, okay, everything's working, it's pretty impressive. He talked about one time when he, during the lunch break, he coded like a ray tracing from 0 to like a big ray tracing example of a couple of 100 lines of code. And if you've done that, you know that it's like, to do that you need like a little bit of math. Like you need to follow the traces and make sure that like you do the math properly so that they bounce around, and like to do that in an hour, yeah, that's like a cool party trick. Oh, that's right. Anton was inviting all of us to his off-grid cabin. Yeah, where everybody can code how they like in their own little cabin. That was the metaphor. I have both chats open. I just need to read them one after another. But to be fair, Twitch is a smaller chat usually. So let's see. Let's see how this one goes. How do you prefer to be called, Lucas or Łukasz? At this point, I'm giving up on people managing to pronounce my name properly. So, like, my literal pronunciation of name is Łukasz. So the other one, like Łukasz, if you do it like with an English accent, like British or American, it's fine. But I would turn my head if somebody would call Lucas as well. And people in the Germany, they sometimes say Łukasz now. which is another layer. The Germans. Are those arrays as large as your background puzzle? There's 4 pieces now that are not there. 4 pieces, man. Okay, I don't even know how to write down my last name to be pronounceable in English characters, but you pronounce it as Ściga. And by the way, I can see Polish surname, Polish nickname on Twitch, so there's definitely a subset of the viewers who know how to pronounce it. How long will this stream go? Well, it's probably something like 2 hours, and if all goes well, Anton should be there in like 10 minutes or so. But Relar, you are from Poland, right? Correct? Warsaw? Array of things of a slice. What? Yeah, like sh, like SZ in Polish. It's usually in all the other like Slavic-like languages is the S with the, I don't know, like a angular bracket on top. It's the same. For example, author of File Pilot is Croatian, and his surname is Krajacic, and one is Chi, and the other one was Ch. And a C with like an angular bracket turned left is the Ch. Hello, Alex. Oh, hello, Nuno. Nuno, the author of Arc VCS, is in chat. And by the way, fan fact, Arc VCS is made in Jai. From scratch. Yo. Is Arc VCS gonna get 100? Is it gonna get 1.0 in February? January? Tomorrow? No pressure. No pressure. Arc VCS is a VCS version control system that aims to solve issues with common issues when you have binary files in your project. Because surprisingly, Git as a version control system is nice as long as you don't need to do any binary files. Then if you embark on Git LFS adventure, it's like good luck, man. If you constantly update binary files, wow, it's rough, man. And the common thing to do it when you have binary files, for example in games, it's quite often, is to not use Git and to use Perforce. And Perforce has its own set of issues. And Nuno came to Łukasz podcast to discuss in detail the pain points from his experience, for example, working at CD Projekt Red, cool company, Witcher 3, Cyberpunk, maybe you've known it, you've heard about it. And he talks about Arc VCS and his solutions to problems. You should check out arc-vcs.com. And a cherry on top is a fun fact that Nuno was like a fourth person on the planet who got his hands on Jai programming language from Jonathan Blow. And the Arc VCS is a graphical desktop application which you can run and is built in Jai. Arc may get 1.0 in March. Ooh, rough. I was expecting, honestly, like tomorrow, it's Friday, maybe by Monday, like if you work on the weekend, squeeze in some of the features. So there are questions, is Arc already usable? It is usable. You can take a look. The Arc website has a better outline features, what it has, what it doesn't have, what it lacks, etc. Does CDPR use Arc? No. You can imagine that like, hey. But
hello.
Wait, compression, internet compression, nice.
Uncompressed.
Uncompressed. Look at that sound. Damn.
I don't see my video, so I'm just guessing.
Yeah, so it's the layout's gonna break. I can put us both now for intro.
Yeah, doesn't have to be.
I will lower your volume a little bit. Look at
I'm
this.
moving all around. Maybe test off this. Oh, nice cup.
Yeah, IKEA. I mean,
IKEA.
Do people in US even know what IKEA is?
What are you talking about? We live in IKEA, man. This is your number one
really?
export. Yeah.
What?
Yeah, IKEA is like all the rage. It's like the Costco of Europe. It's like we have Costco, and Europe's like, oh yeah? How about IKEA? Way bigger items. What do you think about that? And we're like, all right, that's pretty good.
But like, we don't have Costco in Europe. Like, we don't export stuff from Costco to here.
Well, there you go. Maybe it's time for
hey,
that's when the
business idea. I'm gonna reach out afterwards.
We're like an 18th century merchant. Like, I've heard in these lands there's a shop exactly. Large.
I would like to rent a ship with big sails. Costco is so good. When I've been in US recently, it was all Walmart.
Every time. Yeah. Every time. I mean, yeah, that's a thing too.
And also like so much sugar, man. Like half of this store is fucking sugar, man.
Yeah, the sugar is real. Like, yeah, we have a monopoly on that.
Anton, are you prepared for the second part?
I'm prepared.
A large array of things.
I'm prepared. I feel like mentally it's the third part because I basically like walked you out of the C++ and I was like, now we're in my domain and now it's part 3, the finale.
Oh, like you.
That's how I feel.
Okay.
Yeah.
So in my head, there has been for the audience as well. There has been This is like a fourth episode of a sort of new series that we're trying out, which is I invite people and force them to code. And the first episode with Anton was where I was actually like trying to well force some ideas, especially from the modern C++, on poor Anton, and it's already available on YouTube.
I resisted.
And yes, Anton was doing his best. Like he basically has done like 2 projects simultaneously, one with my suggestions and one in C, which would be like his version of my business requirements, and that's already available. It's about Meta image registration API. It's really cool. And then there was episode with Ginger Bill where we're doing async IO for Odin, like how he would design async IO. And this one also went up recently, and it's publicly available now on YouTube and other platforms. Now there's unreleased 3rd episode with Anton when we started so-called large arrays of things, which is a technique for state management for basically the entire program, entire project, where you, instead of putting things kind of randomly and scattered around, you keep them in big arrays, and the entities themselves have info how to get to other entities, related ones, for example, parents or siblings, which is a very cool technique. And now for the fourth episode, we're gonna finish off the large arrays of things, hopefully, and show this in action, how you would actually do it, because there are a couple of things that are left, and maybe it's a good moment for you to sort of take over and like present where
we're at.
Where are we?
Yeah. Let's do
And
that.
people are already saying ECS. Look, if you say ECS and Anton sees that, he's gonna freak out. Okay, don't tell him.
I'm not gonna
ECS.
freak out.
It's
I'm
like,
not gonna freak.
it's large arrays of things. If you wanna go far already, you can say FATSTRACT. Okay.
Yeah.
Or if you wanna be super like edgy, you can say Plex. If you have seen Better Software conference talks,
If you
from
know,
last
you
year,
know.
Plex. But if you have not seen it, FATSTRACT. But ECS, please, no.
We'll just get mired into discussion of what it is and what it isn't, because it's like art. Everyone's like, that's not art, that's art. That's like, that's ECS, that's not ECS.
Yes. And also everybody can have an opinion.
And not everyone needs an opinion, right? Really, come on, people. Not everyone needs an opinion. Everyone can have an opinion. So
I would go on a tangent here of the opinions. Like, I don't know why in my, like when I was in school, like people were insistent, like you should have your opinions. Like, no, you shouldn't. Like sometimes you should just listen, and that's it.
you don't know what's needed. Yeah. So true. Yeah, I think everyone, myself included, could benefit from that wisdom.
Okay.
So this is where we ended up. Can everybody see the screen and my private new documents? Look at
Oh,
that.
damn. With
Secret document.
IRS numbers and whatever.
Yeah. Yeah, so where we ended up is I was like, you know what if we just make an array of things, and you can imagine these are like your game items or your app items. Like I use this architecture for the abstract syntax trees inside the not calculator, same kind of thing. So you have a bunch of nodes, they're connected, they have some properties and things. But easier to think about it in terms of like game stuff. And at the end of the last session, we ended up here. I'm not going to code in Visual Studio, but just to kind of like refresh people and also make sure it still compiles. Yeah. So we got our werewolves and we got our Lukash here walking around, and they all wiggled too much because we were saying hello. But that's kind of what we're looking at in this file here. And rightfully, we skimmed over a lot of details. So this stream is like, how can we put some of these details back in? So a couple of things we skimmed over. When we remove things, we just like set them to false, but that's not really going to work long term.
Can we do like a overview of what the thing is and how the array looks like and what are the pointers but not pointers, so that like everybody's on board?
Yeah. So we have this struct thing, which has a kind. So these are like, you can have players, trolls, and goblins in our current simulation, and then they all have positions, rotations. So this is kind of like your fat struct that Lukash was talking about. So you move them around, you can render them. And then we added this cute syntax sugar that you can like check if a thing is a thing, and it just basically says, is it nil? So, you know, this is just like my first struct kind of thing that you'd write. Alex used to call this like 15-year-old code. And it's like our quip on Dreams was like code like a 15-year-old with 30 years of experience. Like that was kind of the code style. So, and then we had this thing called things, which just is a flat statically allocated pile of things. And when you add a thing, we put it into a slot. And so we had in the other, I'm not going to redraw the diagram, but basically what we're implementing is called a slot map in some circles. And there's like an Our Machinery article about it on archives you can find. And the idea is like, well, we know that we're probably not going to have like too many things. So we're just going to allocate a fixed amount of spots for them. And then when they come in and out of existence, we're going to add them and remove them from these slots. So you just find an empty slot, put it in, and when you remove it, you make the slot empty again. So most of what we're going to do is like improving that because, you know, this version works, but it's got some problems with it. And then to refer to things, we have a thing called thing IDX, which is just an index into this array. So in the beginning, for example, like this is our game reset function. So we just say things is new, like a blank things, and player index, which is our kind of global player. We add a thing and we get back an index, and then we can use that index to set its position, the sprite of the character, the color, and likewise, when we make our 50 trolls, I guess they're werewolves because we changed the sprite, but you know, there you go, game code. So we make a bunch of them and then we set them and stuff. And then when we actually move the stuff around, so when we're doing our game update, we can just do, can we get the player? So things get player and we get player IDX. And this is where we use that nil thing. If we don't find it, we don't do anything with it and we just can't update. But if we do find a player, we take some inputs, and this is our movement code. So we move them around, and this is our wiggle code, which wiggles the person as when they move around.
Okay, can you increase the font size, or is this max?
No, we can.
Ah, perfect.
Like this is max.
Okay, that's perfect. Now I wanted to like quickly jump in, interject. This like mentally can be juxtaposed with a sort of other ways of state management for people that like see this, because if you see this, it's kind of like, yeah, it's obvious, right? Like we have a things in array and they have indices, and like we can call an index, and like if something's dead or not needed, we can just clear this and it's fine. Like the, let's say, common or other ways to do it would be to throw in things into the vector that would have a dynamic size, which would be problematic if it would be rebuilt, because the size of the vector would hit the capacity and now it would need to be restructured. So this avoids this problem. It's a statically allocated array and the things are there and you can like expect them to be there. And you're doing the slot management to fix or like manage their position and their lifetime. And this is also to be like a little bit juxtaposed with the idea of like having, you know, players as an object somewhere, you know, and having them scattered around and like breaking apart. Like here's intentionally things are being put in a player class that could be split into like 3 different objects and like dynamically allocated and be like kept as pointers, right? Here you have like a one big thing. That's why people call it often fat struct, where you sort of shove in things, even if sometimes you don't really need them, you still want to just put them so that you have one thing in place and you have this sort of base entity, sometimes it's called, but we don't want entities. We don't want entity component systems. So we want structs and things.
Yeah, and I think, you know, there's a natural desire to be like, yeah, but I want it to be clean. I don't want these properties that I don't use, and I want to have like strong typing. And there's value in there, honestly. The real question is, how much does that cost you? And the context for this is sort of like small indie apps. Like, you can write big stuff like this, like the internals of Modeler and Dreams look roughly like this with a bit more, you know, shenanigans going on. So you can do it, but it's like a harder argument maybe there to sort of say, well, you have a big team, you want static typing, you want this. Okay, like that can be a discussion. But if you're a solo developer or a small team, I've tried writing games using this method and kind of more statically typed things. And inevitably what I find is that, you know, I don't have 8 hours a day to write my hobby project. I got like a couple hours here and there or whatever. And so if like even 15 or 20 minutes of that is spent refactoring types, I've just wasted like a bunch of time. And so, yeah, this is a bit messy, but it saves you time for a small project. And so it's the kind of thing where you should really consider your team size and what you're building in the kind of code you write, because you want to be efficient. You don't have like the power of a large organization or even a large team. So optimizing for like flexibility of the code, and also you don't necessarily know what you're going to do with the game. And so this keeps it like super flexible. So you don't have to be, you know, if you add a new monster type, which is an elf, and now it's very different, you're like, oh, I need to change, you know, how these things behave. Whereas you just add some properties and kind of make it a day. So, you know, just to be clear, so I don't get like roasted, I'm not saying this is the best way ever to do everything, but I think what I would say is that the kind of bang for buck ratio is very high, and you should really like pause before leaning into more structure. If that makes sense.
What are the issues with the code now?
So the issue with the code, and by the way, I can't see your video, so I don't know if there's a way to see it so that I could see if you're looking upset or happy or confused, and then I can like react in kind to change stuff.
I can voice those emotions.
Okay. I will listen carefully to your emotions over voice.
Smiling.
So the number one problem I would say to start is that, so here we sort of say, okay, we're going to add a player, right? And then we're going to set it to the player IDX. And that's great. That currently works. And I add a bunch of trolls and it all works. But if somewhere here, for whatever reason, we do things.remove player IDX, what that will do is it'll remove the player and it'll free up the slot. So we can see it here, rem, if the index is valid, which it is, all we do is we set the used index to false. Okay, well, not too big a deal. Now this index is freed up. Now, player IDX, if you try to, you know, do this kind of thing, that will give you a nil value, and you'll sort of like poke a nil, which is not ideal, but it won't crash you or anything. So this is okay. The real problem comes in is if you say, okay, actually, I'm going to do, you know, other player IDX equals thing at player. Now you add a new player, and then and then try to use the old index. It will actually point into the same place, and you won't know. Other player IDX will be identical to player IDX, and you can get these kind of like effectively garbage memory style errors where pointers basically point into the same place. And that's because as soon as you removed, all you did was, you know, you set the use to false, and then when you add, all we do right now is we just look for the next empty slot, and then we grab it. And so right now, luckily, the next empty slot will keep going until we get to the max. But if we want to recycle slots, this will become a problem. So the first thing we need to do is upgrade our index so that it can detect this sort of thing where when something is removed and added back in, we no longer have this kind of like mismatched reference. So the way we'll do that is we'll actually use a thing ref rather than a thing IDX. So we're actually just going to dump this entirely, and we're going to say a reference is an IDX and a generation counter. And so the way this works is now whenever we think about our slots, and maybe this will be easier, I'll draw it out. So before we had all of our we have all of our slots here, and they start out empty. And so we added for example, maybe we filled this up, and then we add our player here, and then we say, okay, we're going to remove the player, and so we say used, right? And then when we add another one, we just add another one again here, and then the index is again 0, 1, 2, right? So what we need is another array full of numbers, which just says, okay, look, yes, we're using slot 2 again, but it's not just slot 2, it's slot 2 version 1. So these ones all get added, or in this case, version 2, I guess. So these have all been added one time, but this one we added it once, and then when we removed it and added again, now this has a number 2. So now your reference is this, that was the worst curly bracket I've ever seen, man. What is that? Okay. So it's going to be your index, which is still 2, but now it's also got this generation counter, which is 2. And so in our code here that we were looking at before, here, player index, this first one that we allocated, that one is going to have a reference of 2, 1. And then the second player that we get is going to have a reference of 2, 2. And so these are now going to be distinct, and that way we can avoid these problems. Does that make sense so far?
No.
No? Okay.
So
great.
In
Good
my
thing I
head,
asked.
my head, if you add a new, isn't the current implementation that like if you add a new one, you would just move to a next index?
Right. Okay. Let's fix that first then. Maybe that's the confusing part. So we don't really want to do this. This sort of sucks. The reason this sucks is because, well, I mean, imagine max things was like 8, right? Well, when you get to the 8th one, you might have empty slots, but the next empty slot right now, we're doing super naively. We're just like advancing, right? So let's fix this first. This is kind of a crappy implementation anyway. Let's do this. Instead of this, and we'll just change this to an int for now, because we're going to get rid of this anyway. So we'll do find empty. And find empty, well, we can just write it down here, just so it's easy, but later we'll make it private. Find empty is just private. We're going to start at index 1 because index 0 is our nil value. So that's a little bit of a gotcha. But all we're going to do is we're going to say if used I, we don't want to, so if it's not used, return I, and if we didn't find anything, just return 0, and that's going to be our nil value. And so now it's going to say, okay, find an empty slot. All this is going to, we can do better than this, and we'll talk about how to do better later. But for now, let's just sweep all of our max things and find the first unused one and then return it. And so what that will do now is we don't need this next empty slot stuff. We just say find an empty slot. We'll make that fast later. If we found a slot, we're going to reset the thing in that slot, set its kind, and say used slot is true. Otherwise, we're just going to return nil again because we're returning indices. Does that make more sense now that we're going to like grab a slot that's been used before?
Yeah, now we're going to hit that.
Yeah, and we need that if we're going to actually use empty slots. Otherwise, we'd run out of slots after we add, 8 things. And even if we remove them, that could be weird, right? If we add 8 things, we remove all 8 of them, and now we can't use this data structure anymore. Come on, this ain't amateur hour. We don't roll like that. That really would be 15-year-old code, right? So, yeah, okay. So now, does this make sense that we're going to have to do some kind of like uniqueness tracking of each slot? And so an easy way to do that is to add this, simply add an integer, we'll call it generation counter. Some people call them just counters or unique. Well, it's not really unique IDs because the reference is more like the unique ID. But okay. So we make a generation, and then here, remember everything is 0 initialized, so we can imagine everything is 0. And so here we simply increment the slot. So every time you place something into a slot, you bump it up. So things will start at generation 0, and then they'll go to generation 1, and so forth. So, and then instead of returning the raw slot, we now need to return something better. We need to return the reference. And so here, instead of returning a thing IDX, we'll return a thing ref. And that will simply be our slot, and then the gen of the slot. So now we're handing out these references. And if we don't, we need to return what would be like a nil reference. And so I typically like to do this kind of thing so that it's really explicit that it's a nil, but really that's just return 0, 0. But we can maybe do something different here if we care to, but this way it's like semantically we know that we're returning that. So far, so good?
Yep.
Cool. So now when we're accessing things, we no longer access them by thing ID, we access them by thing ref. And now this is a ref. And now, this kind of code where we're checking if it's like smaller or bigger, this is actually going to show up. I mean, it's already showing up here, right, with remove and things. So really, this is another one where we want to add some helper functions. So add some privates, and then we can do, so we call it deref. So this is very much like dereferencing a smart pointer or something. So that is, the job of this function is to take us from a reference, which is this kind of more complex thing, into a raw index. And because we have nil, again, it's really easy. If we fail to deref, we just return 0 and everything is going to be fine. So we'll take this part. So we'll say if the index is greater than 0, like if it's not nil and it's not negative, if it's less than max things, if it's used up because we can't deref something that's not a used slot. And now we can also say and if ref gen equals gen ref IDX. And here we all need to use our ref IDX here too as well. So now we're checking a bunch of things, including the fact that the generation counter is the same. So we're getting actually. And if that's true, then we simply return ref IDX. Otherwise, we simply return 0, which will point us back to nil. Does that make sense?
Yeah. There's a bit of a discussion on the YouTube chat.
Yeah, let's do it.
So we can do a bit of a break for the discussion. There are questions about cache misses. And maybe I'll start an answer. The question is basically, if you have a big entity, doesn't it make it miss the cache more often if you have more data in it?
It's very true. So exactly true. Now there's a couple of things to say about that in order of kind of like provocativeness. Number one is how big are these really? And so when we wrote Modeler, I did this test and we use a similar internal structure to this. And what I found is that the entity has to kind of get to about a kilobyte in size before it really starts to be super noticeable. And I was targeting the app to take care of about like 100,000 to 500,000 entities, which is sort of like a practical amount for for modern computers. So first question to ask yourself is like, yes, you can make it peak perform, but this is pretty convenient having it all in one fat struct. And so maybe it just doesn't matter. So an easy thing to do is run a benchmark and be like, how many things are you expecting to see in your game? And I think this is in general like an annoying but good habit to have. Like it's hard for me personally because I just always want to make everything super duper optimal, but it's really handy to look at the trade-offs and be like, okay, I can do something better, but you know, this is pretty convenient. Like, should I really give this up? And, you know, obviously measure before you optimize. And so already this is going to be way faster than like a bunch of heap allocated smart pointers. So maybe you just like take that win. Next thing you would say is you will get cache misses, but one simple thing you can do is if you really care is you can actually manually order these things by the usage. So for example, I know I'm going to always use kind, so that makes sense in this position. And I also know that position and rotation are going to get used together. And so let's say that I have this like egregious thing of like, you know, char fat buffer 1024. So I've got this like huge chunk of memory, right? If I do this, so a cache line is 64 bytes, right? If I have it here, it's kind of like no big deal because if I'm doing, for example, positional updates like animation, they're kind of going to touch these things, position, rotation, animation. They're not really going to touch damage or health or something. That's more like game logic stuff. And so if I put the fat buffer here, yeah, the cache will not have like full occupancy with my stuff, but it won't be like super duper bad. Whereas if for whatever reason I put the fat buffer here, that's kind of really bad because now I'm only going to get one useful item per cache line kinds of stuff. So knowing that stuff, you know, and again, this is a very tiny entity, so it doesn't even matter. I don't know how many bytes this is, but like it'll probably fit in the cache line. But when your thing starts getting really huge, you can kind of play this game of rearranging your struct to make the cache not so bad. Okay, but if you've tried those things and you're like, no, my game is about real-time strategy of 500,000 units, I will not be good enough for this, right? Okay, fine. So what we do for that is we actually split this up. So conceptually, the reason I'm writing it like this is it's easier for us to deal with the struct. But in practice, what you can do is make arrays, what's called like an SOA or structure of arrays instead of an AOS, which is array of structs. So instead, you would put all of your stuff in here. And you would just literally break it down by piece. Okay, and then so on and so forth for every single property. And so this is how Dreams works, this is how Modeler works. We don't have this. We have all the properties.
Close. LED component system, so close.
So close, but not quite there. Well, okay, so actually this is how early entity component systems looked. That's kind of where this came about, right? And the thing ref is basically your entity ID. My point is you don't really have to call it that. Like the components part is where it feels like people get mired in discussions of like, what's a component? And it's like, I would call this maybe like an entity and properties system because there's not really like components. There's just a bag of properties. And so in Dreams, we call them things and thing props. And there was no real components and there was no systems because it was just a bunch of code. So if you want to call the code systems and you want to call the properties components and you want to say like, these three properties are part of this component. Okay, and then I think people globbed it up and I'm like, I'm not sure that's actually helpful.
I also wanted to like make sure that people follow because like you introduced the term cache line. It's like the way the cache of CPU works is that it's if you load something into memory, like you load something to a function, like the bytes afterwards will be loaded, like the memory will be split into like lines. So whatever is afterwards will be loaded, but you don't have direct control, of course, as a programmer to it. So the idea is that you need to make sure that your layout of the struct, just literal order of things in the struct, is so that like if you're gonna use this property, and this property often together, if they are close by, then you increase the chance of them being in the cache together, right? So you will not go and fetch the memory. So for example, in like, I don't know if it's still there in the console games, but I know that like in earlier console games, you would just have a comment saying, hey, here's like where a cache line starts, and here's the next line, and here's the next line. So kind of you just visibly see, and you maintain the comment so that like people know what is there in the cache line, what's not. But when we're talking about cache misses and not, I feel like we're like in super optimal now territory, and this is for most applications, it's like we don't get there usually, right? Like, it's good to know this and like have this in mind when you're doing something from scratch, of course. Like it's there. Like more often than not, you kind of you need to think more about like the system like this one to even have the ability to do that, right? Because like,
exactly.
In the other situations where you just have like a std vector of std shared pointer, you just like no longer have the ability to do that. It just goes.
Right. So that's that's a really good point. Part of why I was like, okay, being loose here is because my point is, if you're in this ballpark, you can make this transformation pretty easily. Whereas if you're not anywhere near this ballpark, you've got like no hope, right? You have to do a big rewrite. So part of it is if you just do some of these things that we're talking about here, even if you sort of do them lazily, like I'm doing them here, you're so close to being able to optimize it. So this is what I would call like optimizable code. So rather than doing the what some people might say, oh, it's premature optimization to like order for cache. I'd probably agree, honestly, in this kind of thing. If I'm making an indie game, the chances I'm going to have like hundreds of thousands of things, it's pretty low, unless that's like my game. In which case, okay, fair enough. It's not a premature thing. But just because I'm not going to do that optimization doesn't mean I don't want to be able to if I need to. And I don't want it to be like this massive rewrite to get there. So I'm trying to like stay close to optimized code, but not necessarily pay the cost to get there every single time, which is like the thing that I think is the straw man of a lot of people when they're talking about, low level programmers or handmade people. It's like, oh, you're trying to optimize everything to the microsecond, and it doesn't have to be. It's like, no. I'm trying to write the code so that I could optimize it if, the game design changes all of a sudden and we do have 100, 10,000 things instead of 1,000 things or whatever. So that lets me kind of keep the mobility. And so we could actually, Lukash, you can decide, but we could actually go this SOA way and retool it. All this changes. I was just doing it as you were talking. Instead of like getting the thing and then, we, since we have this deref function now, we've wrapped this stuff up. Now we have this nice deref function. Get just becomes return things deref ref. Because as you can see, if deref fails, it gives us a null. So it just gives us back the 0 thing, which is the nil. And if it succeeds, it gives us the thing. So we can just remove all this code. Look at that. And because of nils, we don't even have the if case there. So this is the kind of fat struct version, which allows for code like this, where you just get the troll and then start setting it, which I find really convenient, especially for small projects, because it lets you just like reason about your structs easily. You don't have to do any gymnastics. But a more prudent thing is this approach, where for every property, you actually do have getters and setters. And the reason for that is because for one, it means you can do this SOA transformation basically under the hood without anybody ever noticing. Because, here we're using the struct itself as kind of the API, which means if we ever make this transformation to SOA, which is this arrays thing for better cache performance, now we have to change all the call sites. It's not terrible, but it's kind of annoying. You have to switch all the getters and things like that. Or you return something like a proxy struct with references inside just to kind of keep that API looking thing. It's a bit more boilerplatey, but this seems easy. And also this code can be generated if needed or done via macros or all kinds of things. So you don't necessarily have to write one of these for everything. But even then, it's like Dreams literally wrote all of these by hand. It's like a couple of dozen things. But the big advantage you get here is that I was going to get to this later, but it's kind of important. In here, we're doing this get here. And this get might actually return a nil. And we talked about that in the previous stream. It's like, oh, that's kind of nice because then I won't crash if I try to like reference things. Well, the thing I kind of glossed over is that if you get the nil back, now this is a nil troll and you're like setting a bunch of stuff on the nil. So the nil value is getting kind of clobbered. It's no longer got the nice zeros we want for everything. Because remember, we're using the nil as a kind of default value everywhere.
Yeah. And
right?
you can then find out that nil has a position in your world and it's being updated.
Yeah. And it means that if you want to write like really clever code, like, say you have some entity and then you're like entity dot position plus equals entity dot velocity, right? And you're like, I am so clever. Nil velocity is 0. So nil will just simply no up and add. And you're like, okay, great. But somebody set the nil velocity to something else. And now you're like, nil is flying around. That's when you get those kind of fly around random entity bugs in games. So there's an advantage to like guard your nil. And so in the original code, I had stuff that was like doing a janky version of that. And it was like saying, hey, if your nil is not 0, like assert. There's a clever trick you can do, which is if you declare your nil in read-only memory, which you can do with compiler extensions, you will actually get a crash when you try to write to the nil. And that's a bit better. But then it kind of like, you can like, I learned this from Ryan recently. It's like, if you just mark the memory read-only, you'll get a trap, which makes sense, right? It's the same thing as you'd get if you write any other read-only memory. So that works as an assert, but then it's like, well, I was selling this benefit of like, maybe that's great for debugging, but for runtime, it's like, I kind of don't want to crash. So a way to, in my opinion, do better than that with a bit more code is I would put the setter just basically ignores the set call if the deref fails. So if you give it a nil reference, you just simply refuse to set anything for that slot. And so that way your nil will stay pristine and untouched. And for bonus points, if you can in here say, hey, maybe in debug, I say assert, false, someone tried to set something on nil, and basically alert the programmers, like if you're not expecting these kinds of tricks where you're setting values and expecting them to like pipe to dev null kind of thing, you can catch those, right? But then in release, it does nothing. And so you don't crash people's applications. So you have this really manual control over effectively a pointer dereference, which lets you do all sorts of fun things. You can check if the reference is from, like, your reference can be more complicated. So for example, one thing I believe we did on Dreams is we actually also had a frame counter. And so we knew when each reference was created, like which frame. So you can say, hey, you've got this reference that's from like 30 frames ago and you're trying to use it and the generation's dead. And that lets you track down who created it. You can put whatever you want in there. You can put like, maybe don't put stud string, but you can do like name. The world's your oyster. You can add lots of debug information here and catch all sorts of bugs, both for gets and for sets. Does that sound cool?
Yes.
Yeah, we're on board. Okay, I won't do that right now, just so that we don't have to rewrite this, but maybe I will. I don't know yet. Probably won't have time, but we'll just
my idea would be to go as high level as possible.
Yeah.
So that we finish off on the concept level, and then depending on how much time we have left, we can do sort of dig-ins and discuss things. I also pasted a link to submit questions to people. I've seen a couple of questions relating to this, a couple of questions sort of more generic. Put them there, and then we will address them depending on the time availability. Because ideally, we want to get to somewhere when we have like, hey, here's like a implementation that you could use.
Yeah. So here we're using our deref now to do the get. So that's nice and clean. Remove, similar thing. And this is another sort of place where we can do this cutely. We can just say used deref ref equals false. And so we'll just change this to a thing ref. And again, kind of cute because if deref fails, hits a nil, used equals nil, no problem. Eliminate a bunch of logic, shabam. So now internally we can start to be kind of loose about using deref and just poking arrays values. Got to be a little careful, but you know, not bad. Yeah. So. And we can check things for nil easily here as well, right? So let's see, do we have any more thing IDX? Yeah, so this becomes a thing ref. This becomes a thing ref. And that's it.
So we turned the thing IDX, which was the index, into the thing ref, which is index plus generation.
Mm-hmm. And now this kind of thing will work correctly. So when we remove the player, it's going to get well, nothing will happen when we remove it, but when we add the other player, the generation will bump. Other player IDX is going to become, you know, let's say 2, 2, whereas this one was 2, 1, as we talked about earlier. And then when you do a thing get, you're going to say get to 1, and that's going to say, nope, I don't have that because the generation counter mismatches what's currently in the array. So you're going to get a nil, and you know you're going to poke the wrong position. But we just discussed how we can
That's
avoid
smart.
that.
It's like,
Yeah.
I think we can also mention here that like the other way to do it, like the normal way you do it, you would get either like deleted memory, so you would crash on accessing this, or you would devise like a huge system to track what's deleted, what's not deleted, and maybe delete, but like only at the end of the frame, and it's like crazy amount of like machinery going on
Yes.
to actually solve this problem. And here's like a super concise.
You just need that.
Yeah.
Like, I haven't looked at the guts of a weak pointer, but I believe this is the same semantics as weak pointer, except I think if you attempt to dereference a weak pointer, it's just going to like assert on you or something, exception, I'm guessing. I don't think there's no concept of a nil there. And this is kind of like a combined nil plus weak ref sort of thing, but just done manually and simply. And you can read this code, which is a big advantage over a weak pointer. Yeah. Okay. And I think it's just as safe, especially if we do, you know, I'm very tempted to go to that SOA version and add getters and setters. But if you have those getters and setters, you're like actually more bulletproof than weak ref. Like you won't crash. You can catch everything that you want during debug by putting asserts in those places. And you still have all the guarantees of, you know, not having use after free and all of that. Now, if you're like me, you're saying, okay, but actually, if
What's this accent?
if you remove and add, like in a loop, 4 billion times or 2 billion times in the case of an int, you can actually get a generational ID collision, right? So if between these two places, you add 2 billion things and remove them, your generation ID may come out to be 1 again here, right? In theory. So that kind of thing keeps me up at night. Practically, again, like same as cache, don't worry about it. Most people don't even use a full int for this kind of thing. They'll use like maybe a couple of bytes. And it just doesn't happen because if you run the math, if every frame you do that, you will still kind of like run for multiple days, I think, before anything goes down. But that is a thing, so I'll mention it for, you know, what what's the term for full transparency. But you can also do like in 64 and now just like, come on, man. If you really can't sleep at night, run with Instant 64. It's super, overkill, but it's still probably less memory than a weak pointer, so you're still winning. And so if you're really, 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 really OCD and can't sleep, just throw more bits at it.
What if you're now OCD that your cache line got fatter?
Well,
And
yeah.
now if you have an array of thing refs, then you're like, no, where's my space and cache?
Where's my
Damn
space?
it.
That's right. Yeah, no. And so then it's like, you got to exercise restraint. Like part of this is being like, look, man, we're being pragmatic here. And like, that's a muscle. Honestly, I think this is like a really, it's a thing. And I think this is how people get into, okay, there's nothing wrong with trying to solve that problem. Here's what I'll say. You absolutely should mess around with it and think about how you would. But when you solve it, look at the code you end up with and look at the code you started from, and then make a clear-headed decision like a product manager of whether that was worth it. Because if you go full bore and you end up with weak pointer, did you win, really? Like you won this game in your mind that this will never sort of collide, but you lost like every other game, right? Ever, basically. And the same thing is sort of true for all of these things. And in a way, when people are like, you're doing premature optimization, in my mind, I sometimes feel like, well, maybe the other camp is doing like premature typing, and like you add all this type and guardrails like before you've actually had problems with it, if that makes sense. So you might be solving these problems, but they're not really problems you have. So unfortunately, there's no, it's like hash maps, right? Hash maps kind of like, if you look too closely, you sort of get a little sad because you're like, but what if it's collisions? It's like, yeah, it's just, that's how life is, man. Or like bloom filters. Don't think about it too much, but think about it. You gotta like think about it the right amount. That's the key. And I think that's where comparing the code before and after and saying, look, which one do I want to work with and what does it buy me? The other thing you can do is just back of the napkin kind of analysis. Not enters the chat. If you do like, how many seconds are there? So like 2 to the 31, right? Divided by 60 frames per second. Okay, so if every second you spend a generation counter, that's how many seconds you have, and how many seconds are in a minute. 60. How many minutes in an hour? What is it? 60 again, right? So we're looking at 9,000 hours, right? And divided by 24 hours in a day. We're looking at 414 days before you blow a generation counter if you add something every frame at 60 frames per second into the same slot. So if you're not expecting your game to run for 400 days, you probably won't hit this problem.
That's a generous time.
It's generous. And you're generous, right? Now, if you're working on a server, you probably want more uptime than 400 days. Although these days, maybe we just don't roll that way. We just restart that Docker.
Yeah.
But
can I have, look, this is like an awesome application. It's a calculator that has ability to show even like graphs and like awesome author named Anton of this application. I have a feature request to the author.
Okay.
Can we add feature request to the Node calculator, which would be increase the font size? Because like on all these streams, you bring up the calculator, it's like not at all visible, not at all. It's like tiny pixels.
Where is it? Main.
Oh, that's super tiny.
No, we're just gonna scale. Where's the font scale? UI scale. Scale all sizes. I was just gonna scale the font for you. There it is. Font base size, style font base size 20, 40, rebuild. Take the code, go away. Boom.
Damn.
There we go. Feature added. I need to fix the scroll bar.
Okay, now I know 414 days. And it's
414
also
days.
over a year. So I think it's fine. I think
I think it's fine.
even
I think
hardcore gamers restart their not even restart the PCs, but like restart the programs and games
yeah.
at
And
least
if
once a year.
and
It's
if
like
you
a
want to
save.
get, fancier, you just use an unsigned int and now it's 800 days. And how much do you want? Do you want 64 days? That's probably just 64 bits. Now you're like blowing the time of the universe, right? Now, while we're in this ballpark though, someone is still, if you're really paying attention and you're like super on the ball, you may have noticed that that you can do better than that. Now,
Skimmed over something. There's a
we
bug.
skimmed.
Are
There's
we
not a
supposed to
bug.
find a bug now?
Yeah, now this is your test. Can you find the bug? No, it's not so much a bug, but I will point something out. If we actually run this code, and this isn't obvious until you run it, in practice, when you write games or any of these things, you're going to be like adding stuff, removing stuff, and adding stuff and removing stuff. And this code that one might think, if our array of things, we have our 10 things or whatever, we have a bunch of slots, and when I first use a slot, it's let's make some slots. ASCII arts. Let's say I add a thing, and then I'm like, okay, the generation of that thing is 1. The rest of them are 0, right? They've never been used, so a bunch of them are 0. And so imagine I'm only adding like a couple of entities. Okay, well maybe I add my player, and then I add my monster. There's a monster, another monster, right? Now we have 3 monsters, and then the player kills the monster. So then this one becomes empty, and then we add another monster, and this one becomes full, and then this one, and then this one, and so on and so forth. And so what you'll notice is that we're kind of pegging these few slots exclusively, and our generation counters are growing up. Now again, we just looked at it. It'll take like 400 days for you to blow out a slot, but why don't we use these ones? They're there. Can we spread our generation index over more slots? And it turns out we can. So instead of using the first empty slot, like whenever someone kills this monster, there's a way to say, you know what, don't use this slot. It's empty, but let's use this one instead because its generation counter is low. And so when people really try to squeeze bits out of these generation counters, when they're trying to like make thing refs tiny, typically you'll be like, okay, how many things do I have? Thins. If you have like 32K things, well, now you only need 15 bits, right? And then if you can run experiments and be like, how badly is the generation counter getting beat up? Maybe if I can get away with 17 bits of generation, now we can fit this whole thing into a 30-bit number, right? We can compress it. And in fact, you probably don't need 17 bits. Pretty typically, this might be 10 bits. This might be 22 bits or something for more entities. So you can play with this kind of stuff and really bit pack it down. Pretty commonly, a thing ref will actually just be 32 bits total between the generation and the index. If you actually are careful to spread your generational bumping over the entire array, because you'll have a lot of things in there. Does that make sense?
Yes.
And then on top of that, you will also probably notice this use thing is just a bool. So actually, why don't we...
How wasteful.
How wasteful.
Man.
Exactly. So you can usually fuse this used into your generation counter, take the upper bit, blah, blah, blah. I'm not doing that because, we're going to be just bit hacking everywhere.
The find empty function.
Yeah.
Like this is the place where you would decide whether you want like a new generation or to take over like an empty slot.
That's right.
Like you can have more like heuristics or like just check what's.
And we're going to talk about this one next because it seems like also the right time, because obviously right now find empty is like pretty slow. It sweeps the entire array of things, which, usually is going to be a lot, right? Not 1024, like tens of thousands, right? And so this is really inefficient. So the thing that I would want to improve next is finding an empty slot. And so one thing, we had that single index that walked the slots, but we can do a little bit better than that. So do we have any other things we want to talk about in terms of like references or generations before we get to the empty?
So
dealing?
first of all, this is like complete example with all the functionality that is needed, and now we sort of turn into the optimizations, correct?
Well, I mean, yeah, like arguably, yeah. I would say that this is just bad code. This is not even
This
no,
is
but I
like
mean, it's
this is like
yeah,
9-year-old code. Okay.
yeah. But the cool thing is like we just changed this, and then we don't, we can optimize just here, and we have all the tools we need. But yeah, I wouldn't ship this. This is like, well, I mean, maybe for a toy game you'll be fine actually. But yeah, still.
So there are a couple of questions in the chat accumulated, and I will read them.
Let's do this.
Is there any value in keeping kinds of things together, even if they are created at separate times? For example, maybe you need to loop through all goblins to do some special goblin action.
Mm-hmm. Yeah, so so what I've done before is I've done oh god, templates come out. You could just do this, and then I actually end up calling this like a thing pool, because that's the other name for these kinds of things. And so you can be like, if you want to do it that way, you can say, I'm gonna have a bunch of fat structs. So you don't necessarily need to do kinds. You can just, if you like that style of programming where you have struct goblin, struct player, you can make a bunch of thing pools and have one per type, and that makes them kind of managing them simpler. And then you can, in your thing ref, you can put your kind in here. So you can do kind, and when you do a deref, you make a function that dispatches to the right pool. So that way you can have a generic thing ref, which goes across all of your kinds, like a type any situation. So if you want to have like an entity type, which can talk about goblins and players can pick up goblins and axes, it's useful to have like a type erasure semantic where you have like a type any, and you can implement that by dispatching to the right pool. So you can do it that way, or you can say, no, I'm not going to do that. I don't have any type any's. I'm just going to have my pools, and I'm going to index, then you have a goblin ref and player ref, and you know to use them in the right place. So that's all good. In practice, what I found is this. If you don't have like a ton of things, meaning like 30K plus, just sweeping over them and just touching the goblins is fine. Like, even though you're going to iterate everybody, the branch predictor is like quite fast, because it's just, again, you're just branching on kind, and you're saying, if it, down here, you just say, well, we'll do an iterator later, maybe if we have time. But if you just iterate and you say, if it's not a goblin, then just skip it. And then that's my goblin update loop. If you find that, hey, this is, I've got like 3 billion goblins and one player, this is kind of wasteful. Well, just sort your things so that the player's first, or sort your things by
Kind.
You can do that. So Dreams did a bit of that, where we sorted things. And then the problem there becomes, well, now all of your references actually do get invalidated. But there's a couple of ways to deal with that, basically, is all I'll say. You can either deal with it in a sort of transparent to the user way, a similar way to like how smart pointers might do it. You can put like an indirection in here. Or what Dreams does is that if you have a thing ref, my goblin, whenever we do a sort, we also look through all the things, because we own the things. So we know that there's goblin refs in there. We look through them and we remap them as we sort. And so you make a map from where it used to be and where it is now, and you simply fix up all of the references.
Anton?
Yes.
YouTube stream died, but Twitch is still running.
YouTube died? Do you want to try to reboot it, or do we just keep rolling?
Yes, I want to try to reconnect, but it might be that we need to disconnect and go live again.
Sure. Just ping me and let me know.
I mean, you can just stay here, and for everybody who is there on Twitch, it might be that like we're back up in just a sec. confusing piece of things. Not to swear, you know.
I'm also looking at the Riverside link, and part of it is your name, but they dropped the Unicode L and S. So I'm wondering what happens if you don't have any Latin letters in your name, and it just is no longer unique or something.
Okay.
Great.
I will have so much cleaning up with like parts of videos afterwards, but it's fine. I think there's like 7 of them now, and every time I started streaming, there's like a post on X.
It's now part 8.
So it's like part million. Good luck editing.
All right.
Okay, so as far as I understand, we're back on Twitch. We're back on YouTube. If there are people that still can access the old chat and send them the new link, that would be a very kind thing to do.
Indeed. I'll do some ASMR cookie eating while we wait. You guys ready?
You need your mic way closer.
Oh man.
This is like if
so
15-year-old ASMR.
Have my code. This is my stream where we code and eat cookies.
Okay, the chat is no longer available from this one. Like it disappeared. In any case.
No reference.
I just hope people will realize.
Do we still have the questions?
Yes. Questions are on my vibe coded app, which is limited to 1,000 like requests. It's like a free tier of Firebase.
Oh wow.
And when Jonathan Blow joined for a live show, Primagen raided the stream, which meant like 2,000 people from Twitch joined.
Oh no.
And I posted this link, and like within 50 seconds it was done.
You're now a vibe coder that lived the world of like, but my vibe coded app crashed in production.
It's like I expected this to crash. It's more like I didn't want to pay for the subscription, and it got me. Okay, but so the stream crashed actually when I was reading the question, and the question was about if you have something that is just goblins, for example, does it make sense to separate it? I think you can briefly summarize this again, and I will find a proper way to edit this.
I mean, I think what I was saying before is that I have tried that. It makes it easier to like write a loop over all my goblins or over all my asteroids or whatever. But it's also just as easy to loop over all the things and simply ignore everything but asteroids or everything but goblins. Another thing you can do is make another array. You know that you have this many max things, so you can also do something like thing ref goblins. And now you have a bunch of refs to your goblins within the larger array. So if you don't care about like jumping around the array, then you can do it like that. You can also sort your things by type, and that way all your goblins are together. This is something I think we did on Dreams or some version thereof. The gotcha there is that if you change the order of things, all of your thing refs have to be invalidated, which is kind of annoying. The way we dealt with that on Dreams is because everything was in one array, we controlled it, and therefore if we have any references inside the fat structs, we fix them up. You basically keep a map of where things were before and a map of where they go now. So that looks like this. So you call it like a remap, max things, and basically as you loop over everything, you're like, okay, old, in old IDX is like where we're at, in new IDX or like sorted IDX is now like sorted, whatever, right? And so then you do remap from I, which is the old IDX, equals sorted IDX. And then after you've done everything, you just do another for, and then you say, for anything that like is thing dot, my goblin or whatever, dot IDX is equal to, like you fix up the reference, right? You don't need to fix up the generation, but you need to fix up the index. And you just do a remap of that, and then it now points to the right place. So you basically sort, note where you were, note where you're now, and then go over all your references. This requires that you know where all your references are. So if you have a bunch of references floating around, maybe in your UI, then that gets messy and you have to fix those up. So it kind of gets harder and harder if you start doing sorting. So you could, I also noted you can templatize this and make thing pools of goblins and players. But I would say, honestly, in practice, just loop over everything and ignore everything but the thing you care about. Oftentimes you'll find that you can just update everything in one go. And if you need passes, you just do like pass 1, pass 2, pass 3, and maybe pass 4 is just goblins. So it really is like, do you need to? Yes, in theory, it will give you better cache performance. In practice, again, it's like typically where these things start to really matter is like particle systems where you have hundreds of thousands of things. So yeah, I just would say don't do it until you feel like you need to. And if you need to, it's usually, this code is really malleable and you can do it at that point.
Nice. We can follow up with one more question, and then we can go back. So what if the program needs to have a plugin/mod support so that plugins can add their own entity types and data with the cross-plugin interop?
Okay. I have not done that. So I'll just say things from the hip, just to prefix that. I don't know if this would be a good idea. Another way of doing these things is more like there is a way where you can have dynamic properties. So I think it's anytime you're going to be adding kind of properties to a thing fully dynamically, meaning like in code, you want to, like the equivalent of what you're trying to do is things.add property player IDX, and then you're like, I don't know, what are you going to add via your plugin? What are we going to add in the plugin, Lukash? We need a concrete case.
Okay. Fairies.
So we need wingspan. So players now have a wingspan. And so now you're like, okay, and it's of like property type float, right? So you start to have this kind of looking code where you're dynamically saying, okay, player is going to have this, or maybe less dynamically, you might say like things, add property, kind player, wingspan. So you say, okay, all things of kind player are now going to have this. And then you can no longer really do this anymore because, the dot, unless you're doing pre-generated code somehow, which, so statically you won't be able to do that. So then it starts to look like set property, wingspan, right? And like player IDX. So you end up having this sort of code, 3.4, right? And that means you can no longer have the straight up struct. You can no longer even have SOA of stuff. You end up having arrays by property type. So in Dreams, we had like float, vec3, position, like matrix, pose, all these things. So it depends on how dynamic this really is. Like, are you going to compose plugins from floats, or are you going to have more like, weapon stats or something more high level? So you start to get into this realm of like dynamically structured entities. Again, referencing back to Dreams, Dreams had like a big soup of bytes, as we called it. And so there was just, instead of like having 30K entities or things, you just have like a chunk of memory, and then it gets diced up based on property type, and these all get like compile time hashed and all this stuff. So it gets more sophisticated, but I think the fundamental idea of having like a slot defined by a reference and then doing these kind of things can still work. It's just what your arrays and core kind of like holders look like. Like this thing changes, but the used and generation thing I think can stay, and all the slot things we're discussing I think still stays.
All right. Cool.
Okay.
Yes. There were a couple of improvements that you wanted to add to your thing, right?
So the main one is just like, I don't like it that every time we add something, we have to sweep through this list. So like, imagining we have this long list of entities, and, let's say we have thousands and thousands of goblins, and, we delete one somewhere way in there at like slot 1000. And so this goblin is deleted, and then, there's more goblins here. Goblins will be circles, right? And then there's goblins in here, and then there's like orcs and whatever. And then maybe the players here or something. So this empty slot, when I remove a goblin, I want to like jump straight here. And right now what we're doing is we're just saying, okay, let's check every slot up to 1000. It's like, come on, order n for every addition, especially when there's a lot of things. So what we want is really just like to jump to this empty spot. And so the first idea one might have is you just have like a vector of references of your empty slots. So that way, it's sometimes called a free list or a free array. So you might say, okay, we'll do stud vector thing ref. Well, really, we don't need thing refs. We just need an IDX, right? So it's just an integer. And then we could just call it like free slots, right? And so the idea here would be that every time we start with no free, one way to do it is when you start up, you fill up all your free slots with like literally just 0, 1, 2, 3, 4, 5, 6, and every time you use one, you pop one off, right? And then every time you remove, you do free slots dot push back ref.idx, right? So something like that. And so now your find empty just says, if I have something free, grab it. Okay. But we don't want to do that. It's like another array that we have to manage here. So what we'll do is what's called a free list. And instead of having a vector of all of the items, we'll just do, again, kind of like an intrusive list. And it'll make more sense why that's kind of beneficial later. So the way this will work is that we'll have one, So we'll have one pointer, which is like first free. And that will, if we have anything free, we'll point to that. Okay? And then if we go on and we end up sort of clearing another one, we will also have an array here. Again, one for every slot, so just dense. And these are going to be the next free. So this is the next free array. So you have one first tree member and then a bunch of next free. And so what we'll do then is we'll say, okay, this will be the first free, but the next free will point to here because that's the next one that got freed. And then again, if someone deletes this now, we'll say, okay, well, the next free from here is here. And so we'll have these kind of like pointers, bum, 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 which tell us what's the first free item. And then after that, what's the next free item. So then when we want to find something, we just say, who's the first free one? Do we have any? Oh, no. Okay, we have no space. And if we do, let's grab it. And we can look it up and say, okay, let's now, after we've grabbed it, we will update the first free to be its next free. And just effectively clear this link. So it's a linked list that we're managing manually. And so that way we can traverse all the empty slots intrusively. And Does that so far make some sense?
Yes.
So let's do that. So we'll have int first free and int next free max things. And part of the reason I'm doing it this way is because, again, ZII, zero initialization, first free. If it points to 0, points to nil, we know nothing's free. Next free, all of these are 0. Great, all works. So that's why it's like a little, again, like I could do it with std vector, but if we're going ZII, you kind of go full hog, right? And so now you structure it so that your zeros make a lot of sense. Okay, so now when we find empty, we say, okay, well, in fact, we don't even need to, like I was going to say if first free, then like return blah, blah, blah. But we don't need to, because first free, if there's nothing free, it just returns 0. What do we want to return if nothing's free? 0. Great. So we just return first free. And naturally, by maintaining that, it will just all work out. Shebang. So we just return first free. Now it's a question of how do we set first free? Okay. The only problem with this is that if we might want to, well, we can establish like the list. I don't know if okay, the other thing you want is count. And so maybe we can do count later, but anyway. Okay. Okay. Now, when you remove things, you will do whenever we're actually gonna deref this. Now, we don't now in this case don't want to mess up the nil, so we do if slot equals deref, and now we will say if there is a slot, now we're going to deref it false, and we're going to say if not for, so if we have a first free, so if somebody's already in the free list, right, we're now going to put ourselves at the front of the free list. So what we want to do is say first free equals slot. So we want to be the new first free item. But of course, if we do that, we lose the first free thing. And so then what we do is next free slot equals equals first free. So whoever was first, we will mark ourselves to be, basically keep it. And if there is nobody in the first free slot, then we are the first free slot. Right? And then we notice that actually this last piece is the same in both branches, so we can just remove it. So now it's just a case of like, well, if there is a first free, let's keep it around. And if there isn't, we become it. Okay? And now there's like a little bit of, I don't have a constructor, and that's why I was sort of like wafering a little bit. One way of setting this up is that in the constructor, you make all the free slots work out. Because, when you start to add something, we're going to say find empty, but this is just going to be 0. And so you need some way of like actually taking up the untouched slots. And so sometimes people populate that with, pre-populate that free list, or kind of do counts like we did before or something of that nature. And this is where spreading the load over the generation indices starts to become like the question, because if you're always returning the first item in your list, you're always kind of pegging the same item, especially if you're doing a tight loop. And so in practice, this approach is not really optimal. What's better is actually to put the new free item at the very end of the list. So you kind of have this natural like first in, first out kind of thing. And so your generations kind of sweep over, or like your find empty sort of sweeps over the entire list, because like you free it, you put it at the end, you grab the one from the front, so that one gets bumped, and then so on and so forth. Does that kind of make sense? So in practice, I would actually have like a last free and add to the end, but the pointer stuff is a little bit trickier.
Okay.
But you can imagine now with this, you can do order of one removals, order of one insertions, right? Because now you're tracking the slots. And even though you have a list, which is order n, you never have to traverse it because you just want something free. You don't care if it's the first or last or any of that stuff.
I like how you, at some point, you like enter interview mode. And you're like, and I would do this, and like, but this would be nil. So like, you remove this, and you add like if statement. It's like, and it's like, it's like, here's how Anton would do a technical interview. No?
Pretty much, yeah. I'm pretty much on the spot. Yeah. Multi-day interview process to be on the Woocash podcast. And then there's going to be a culture fit. I guess you do in reverse. You did the culture fit first.
Yes.
Yeah.
Then we added the free list to sort of avoid scanning the entire thing for the first free slot and have this a little bit of like closer, tight information. Then we have like adding. That is also, adding is super performant. You know exactly where you want to put this, right?
Yeah.
Exactly. Yeah.
So we have O of one removes, O of one adds, O of one gets using the reference. We have complete protection against garbage memory if we use the getters and setters. We can put breakpoints and we can put asserts if people attempt to access nils, if we care or not. We don't have memory questions. So you trade setting an initial maximum for every kind of memory question, like you pre-allocate, and then that solves. So really, like, you're in this constant battle of removing problems.
Well, this seems like a bit of a hack that you get everything, no? Like, I now need to like find in my head like what's the downside of it.
So the downside is you're making choices. That's the downside. You're making decisions. So rather than saying, I don't know how many max things I'm going to have, I'll make a stood vector. Like, by avoiding that decision and thinking about it, you've introduced you've also picked up, okay, what am I going to do when the vector blows memory? What am I going to do when the vector reallocates and my pointers are invalid, et cetera, et cetera. And then by saying, okay, thing refs, we're going to have nils, it's like, okay, well, that means you won't crash on a null dereference, but it also means you'll not have to worry about that, and you can use this like kind of nil style of just assuming there's defaults. So, or like this kind, we're going to have one array instead of one per kind. Well, we lose some strong typing, right, in here. I don't know, this is a troll. I know the kind is a troll, but, it's not protecting me from accessing, troll.wingspan. Like, this is not an error. So in another implementation where you had strong typing, this would be an error.
Yeah.
How much is that worth to you? Is that worth to you breaking apart the simplicity of this? I don't know. Like, to me, it's not for a hobby project. If you're trying to do defensive programming against people who are really sloppy, maybe it is worth it. I'm not saying that derogatorily, like maybe that is worth, I don't know. But for me as a person, I have written stuff and I don't make this error where I'm like, because really the code always looks like, if
kind
thing.kind, and then you're just like, okay, it's just very hard to make that error in my experience. So you can look at what that buys you. That buys you the fact that you don't have to deal with static typing. You don't have to do const casts. You don't have to do all of that machinery that prevents a problem you just never have. If you do have that problem, all power to you. Like maybe, so I just don't want people to make theoretical decisions of like, oh, the C++ style guide said I will have this problem and therefore I must prevent that problem. And it's like, if you do that, you pile up all the things, you get kind of like modern C++, which is like the lines are this long, out to here, and everything is prefixed with this or that. And it's like, look at it side by side and decide for yourself.
A couple of questions. One is a quick one. Will this code be available?
I don't know. Do you want to make it available? I don't know
It's your call. It's your code.
We could certainly throw it up. I'm sure there might be bugs and things, so I wouldn't want people to wholesale paste it in. Honestly, there's 100 lines of code. It's just from a prescriptive standpoint, I'd recommend you type it in yourself, if nothing else, like from a listing, in the old like Commodore 64 days. Like if you type it in, you'll kind of get it into your bones more. And part of what the suggestion here is that if you type it in, you'll be comfortable modifying it and being like, you know what, I need more performance. I'm going to turn it into that other thing where we have getters and setters. Or you might say, you know what, I do want multiple things. And like, it's not a lot. And so I'd encourage people to just write it themselves and find, there are issues potentially hiding in there. I'm not sort of like skirting around them so much as I think in practice there aren't many issues with this until you get to these other kind of more fuzzy questions. But for like a solo developer to make their first game, like I don't see much problem with this kind of thing.
So you're saying you're gonna do a screenshot of the code so that it's a PNG, and then
it's gonna be a JPEG at this. So yeah, I'll make the screen small enough so that it fits on one page, and there you go. You could take a screenshot of that, and then, so we can do more questions. Or the one thing I would also do is I can turn this kind of thing into an iterator, so that we have something more like for thing iter I equals things dot begin, I not equal things dot end.
Okay, but
if you want,
okay, I'm gonna do a poll. I'm gonna do a poll. It's just like maybe I have some sort of visceral reaction to iterators. I feel like they're hiding this logic. It's like, can we how often are we actually gonna do this? Like,
okay,
it's gonna be in a couple of places now, like.
Yeah, and so I think, we no longer have this, right? Just to be clear, what's the alternative? And that's exactly the mindset. You're completely correctly encompassing the mindset. Okay, so let's look at the actual thing. Let's actually just max things. Okay, so without the iterators, the loop has to look like this. So if the thing is unused, we step past it, because this is no longer this is broken now. This doesn't work because we removed this thing. So the two options are you just sweep through everything and continue. And by the way, this is where I would say if things dot kind I equals goblin, like do goblin stuff, etc. Right? And this is how you do the goblins. And then if you're gonna do players next, you would do player. So you probably might have two of these loops, and then maybe this is like, pass one, orcs and goblins, and then like pass two players, right? And so you might. So this is like a more realistic version of what code you might actually hit. Orc.
Because people are now bringing up like iterators in the chat. It's like iterators. When we talk about iterators, at least I think it's like in C++, there's this tendency, if you make an iterator, you can hide a little bit of logic of like how you iterate within the iterator. It's not the same as a range-based loop. It's not like this item in this collection. It's like, but also it's like hidden if statements and stuff like that.
And I don't think that's always a bad idea. Like surprise twist. Now I go
friendship
full bore. Yeah. No. So okay. So basically, this is the truth of it, right? It's an array with holes. We don't know where it ends. which means every time we do a sweep, we have to go through all things and we skip these. And if you have a bunch of these, a couple of things you might mess up. For one, you should start at 1, not at 0. You could start at 0, you'll hit a nil and probably everything will work out, but you'd have to double check. You need to go all the way to max things, not to like things.count. So this is a very common problem in Lua. Like you're going to have a things.count method probably. So it's really tempting to do this, but it would be incorrect because it's an array with holes, right? Imagine you have 3 items that are scattered through the array and you're like, oh, I've got 3 things from 0 to 3, let's go. And it's like, but it doesn't work because you'll go 0, 1, 2, and then it'll be empty slots, right? Hopefully that makes sense. And in Lua, you have these sparse arrays as well. So that's why Lua tables, you iterate through a thing. So you can't do that. You have to remember to do max things, right? Next thing is, well, this index is not, you can't just actually, well, you can do this right now because it's public, but I'd probably privatize the arrays. So in practice, you need to add like a different kind of element, which is like, or a method, which is like, you know, if things dot valid I, right? And maybe this is the only thing that you take by index, because remember we have thing refs now. And then afterwards, you can either deref, or you have to do like things dot make ref from index, and then this has to check. So you start to kind of like be like, you know, if I really want to do this right, I'm using these indices which are really more internal. You know, maybe this is what your question was like. Well, what's the problem? Well, the problem is you're dealing with a structure with holes in it, so you do have to either keep this boilerplate around for every loop, or you effectively shove that kind of stuff in the iterator. The other thing is, this is the most naive version, which is where we literally walk everything but skip. A less naive version would actually have what's called like a skip list, which would almost be like a free list. But if you have a very empty looking array, sometimes it might be beneficial to skip over the empty space. And so that's when you start to do that. And then another thing is, well, okay, we'll pause there and then I'll show you another way of doing it that's not like iterators, that is actually the thing we do on Modeler, which is an interesting other way of doing it. Do you have any?
Which is a lambda. Which is a lambda
way. Yeah, which is the lambda way. Which,
this
you know, will
like
make functional people happy. Yeah. And the good thing with the lambda is now you can start to do things like traverse the structure depth first. So now you have like maybe parent pointers, and then you could start to do things like traverse all the orcs, and then it will like map your lambda over all the orcs. Or you can say traverse in parallel. So if you know that you're not going to be modifying things based on other things, then you can like parallelize that update. So for example, if you're just going to like make everybody red, that's completely independent. And then you can behind the scenes issue a parallel call over all of your things with the lambda, and you know it's stateless and things like that. So you can start to do more interesting traversals. I don't know if that's the best for games. For Modeler, that made sense because you have scene graph operations like take this subtree, move it there, replicate this. So you can kind of codify these things, and you have relatively few lambdas. I think a couple of dozen we had. But it's annoying to pass the lambdas because C++ lambda syntax sucks a little bit, for one. For two, if you take it as a std function, you have these like small function optimizations that will fall through, and then you'll get like really expensive lambda traversal. So like there's some care that you should do if you want to stay performant with lambdas. Namely, you don't want to do any capture. That is by reference, I believe. And there's a couple of C++ will magically transform your lambda into something much more complicated if you capture a little bit too much, and it's like completely transparent which one it does. So the better thing is to take a function pointer with a void like user data that will never get any slower or faster. So you can benchmark that and just call it a day. If you make it more convenient and take an actual std function that may or may not hit the small function optimization,
like
that cause you a lot of grief.
Every time you pick something from STD, it's like more questions than answers.
That's
like,
right.
What is wrong? Like every time when you have the option to do like an old school C style, or you can do just something from the modern, like you should do the old school thing and just don't even like consider it. It's what I'm so pissed, you know, like where's this like benefit coming from? Not only like there's additions, and now like people need to think through and understand. It's like when the optimization kicks in, like the same with the return value optimization. It's like,
Exactly.
brother, like, and now we have like people to train, and like people need to think about it. It's like team like is involved, like pull requests and like comments and like Jesus, guys,
I broke you. PTSD has, it's like, that's why you need code review.
I didn't know, like,
somebody could say, well, actually, the return value optimization won't actually fire on this code. And it's like, oh God, why?
I am like against the idea of like maybe there will be a return value optimization or maybe it will not. It's like it should be deterministic.
Right. Yeah. So same thing with the functions is if you pass lambdas, I forget what it's called, but it's like small function. If your capture is like less than 128 bytes or something, then it's fine. And if it's more, then like something gets allocated, and then you can benchmark it. But yeah, the only reason I say that is because it's well, anyway, I won't berate into it, but people can play with it if they want. For what it's worth, I would say that one way to split that is to say we had a function like I guess it would be I would call it like apply depth first, for example, and you would say, you know, func pointer func, and then, you know, void star user data. It turns out with some C++ trickery, you can actually pass a lambda to this. And it will work using some template incantations. So you can actually make it type safe, and you can then somewhere else just do like things dot apply depth first, and then you can give it the thing, and like vice versa or whatever. I forget, but some C++ hero on our team fixed this, and it may. Because really what you want to do if this was a pleasant language is you do like things apply depth first, and then you're just like lambda, and then, you know, thing dot set color blue, right? And then you're like, thank you, this was great. But it just doesn't work that way because, well, and in practice the function callback ends up giving you like a thing ref of like what you're targeting, so it's more like things. It's like something like that. And then you need to have, but then you're like, oh, I need to capture things, and it's like, oops, or maybe part of the function signature gives you things.
Yeah.
Whatever, right? But the world's your oyster. So I think you can do tricks here to make this pleasant. And I do think this is worth it for when you're traversing things in a non-trivial way, but you could also hide all this behind an iterator and pick your poison. So like these are your three poisons of C++. And I think for many things, this is okay. I use this like in a personal game of mine, and I just make sure I don't screw this loop up. But this ain't too bad, especially if you wrote this yourself. And it's like 10 lines, really. It's just doing this. It's just basically saying, advance the index. If it's not valid, keep advancing the index. Like that's literally all the code, right? Yeah. And then later, if you're like, oh, this is too slow, you add a skip list and you're like, if it's not valid, jump to the next valid one. And there you go. You've now optimized it. So I think if you wrote it yourself, maybe it's all right. Maybe it's all right.
Okay. We have a couple of questions.
Yeah.
Starting from the top, which is a bit of like left field. Mm-hmm. If you have a bigger game world, e.g. Far Cry, Skyrim, how would you update only entities in the loaded chunk zone?
My gut feel would be to make a smaller kind of like, or like I was showing earlier, I would have, you know, inside, I don't know where this would live, but it would just be some kind of array of current entities in chunk. So you just have thing ref, you know, refs in chunk or things in chunk. And that will be well, it won't be max things because let's say you have like a billion items, right? So it'd be like max chunk entities. So it's just maxes all the way down, or max chunk things. So you have to decide how many things are allowed in your chunk and then make sure you don't blow that and stuff. And then you just iterate those, and then for each thing in your chunk, you deref it and do something to it. So it's one level of indirection, but
I would also suspect that like if you have zones and like in Skyrim, like you would not have them in memory at all, right? Like, and
you mean like if they're far away?
Yeah, it's like static data, config data somewhere living there in a file or something. It's like only when you load a level, you need to get them actually up and running, right?
Yeah, but in like Far Cry or Skyrim, you're streaming those in. So presumably you've got like the chunk that you're currently in, and then a couple of chunks around you, which are like visible but not active. And so you'll have these chunks in memory that, and so what I would do is, I would have a global list of things still, and then I would use pointers to look into it. If you're then talking about like really, really huge worlds, then you might need some, like fundamentally, if you have all those things, you got to put them somewhere. Either it's on disk or whatever. So either you end up with like a things array per chunk, and then you manage transfer of things between chunks, or you have one global giant things chunk, which has like a million items, and then you have like small arrays of references into those things. And then those then you start to get into this question of like, how sparse are they? Do you want to sort the chunk for memory and all this thing? But, also I would say that by the time you're getting there, I think you're comfortable enough to write the optimal data structure for Far Cry as well. I think that's what I would say.
Could it be worthy for a cache locality to copy the needed data to a temp allocator, process it, and copy the result back to the FAT struct?
Probably not. That used to be the case, maybe on like PlayStation 3, maybe, and SPUs and things, but the copy will be so slow that it will probably drown out any benefits you'll get from that. Unless it's something really, really specific. So like, again, in the context of like any indie game, I'd be surprised that would be the case. Maybe for like a particle system kind of, like, it's hard for me to imagine that would be useful. But
would it make sense to have the thing struct as some sort of tagged union, with the kind being the tag, and then a big union of multiple different structs for each kind? That would make the thing size smaller. Any potential downsides to it? Yeah,
the main potential downside is you can't do this SOA split later. So if you make it a union, so a typical thing is like union, and then you have player data, and then you have like goblin data, org data, org data.
What's this accent? Every now and then.
It's just my talking. It's just my typing accent. Because if you say things in a funner way, it passes the time better as you type them. It's better than autocomplete. Like, it's more fun, and you get to remember the things. Right. So you could do it this way. And then what that means is that you then, if you are going to do it by structive arrays, you just put these things in your structive arrays, which might be good enough. And we lost that case. But if you're going to do, where's my wingspan thing? Yeah, if you're going to do this kind of like, oh, we lost it.
It's no longer.
It's no longer there. We deleted it. It's in the repo. No, it's not. If you want to add dynamic properties, then it's a question of, are you going to go duck typing or kind of like a little bit stronger typing here? And people just have different preferences. Some people like to just like share these things, or maybe you have like your shared data, right? This is like your base struct. I mean, really, this is just ways of doing a kind of inheritance. And this is kind of like your base class, and these are your like in-place derived classes. So some people just like a bunch of properties and then keeping the structure of it, in their head. Some people like to put it into a struct. I think either one can work fine here. This is much more about just like, how do you manage the slots, and how do you maintain stable references, and how do you not crash when things get deleted and you want to reference them. That's kind of like the level at which, but then what you put underneath, whether it's fat struct, union, tagged union, SOA, something more complicated, is kind of like easy to change. That's the good thing.
There's one last question that I think it might be difficult to kind of recover, because it was sort of the point we had earlier.
Mm-hmm.
Anton. With the goblin question, you mentioned a pool.
Yes.
What if a pool can reserve an X number of things in the array?
Yes.
Where you can only spawn goblins in the goblin pool. Would this work?
I can't see why not. Yeah, do that. Sounds cool. So you have like you would have like in first free goblin, and then like, have some defined, you can either do them as defines or something, and how many free goblins you have. And then basically the same API can work, but then if you're kind goblin, you put it in the goblin area, and then when you find a first free, you might return false, even though you have space, but you're out of goblin space. Seems cool. I like it. Try it.
For particles that are temporary crazy amounts, would you use the same array for each particle, or create an object in the particle system and store particles separately?
So particles get into this world where really there's so many of them, and the functionality tends to be so fixed that really like going full Mike Acton is probably the right call, which is like you go like full dots or whatever. Or so what I mean by that is that for particles, people are like struct particle, and then vec3 position, vec3 velocity, vec3 color, right? And you have something like that, and you're like, this is easy, this is nice, and I can do position plus equal velocity and color times equals 3 much brightness. Wow. So, particle update. So the problem with this is that if you want to go like peak rate, you don't actually, and then you don't actually want to do that. Like this turns out to be a position equals add position velocity. And if you want to make this go turbo fast, you want to do it with intrinsics. So this will be like a vector add. I don't know intrinsics by heart, like some people, but effectively this will be like a vector add position velocity. But these are going to be vector add is a four wide instruction. 4 wide, you have 4 wide intrinsics, 8 wide, whatever, like all that stuff. So really, you're wasting like, a good quarter of your throughput sort of thing. So actually, the more optimal layout for particles ends up being SOA. And so you actually have like more code that looks like this, which looks really ugly. But now you can SIMD it because now you can sort of load in 4 positions across 4 particles, or 8 positions, or however many SIMD lanes you might have. And then you're doing your SIMD across multiple particles as opposed to within a particle. So when you get into like hardcore particle stuff, your arrays will probably start to look even more SOA-ish. And then you also don't care about usually you don't care about references to particles because you're not, what the hell is a particle? You don't
Part cycle.
part cycle. You don't care about stable references to particles. Typically, if particles are like fire and forget, you're like, I want 300 smoke particles, throw them over there. You're not going to be like, that smoke puff, bring it closer. That's not a thing you do. And so that way you want to keep them dense and compact. You don't want to have holes in your arrays. So the problem is like a little bit different if you go full bore on it. Sometimes people talk about particles like, oh, I'm going to make my bullets particles and like my rockets particles. And then they're like, I want to shoot a particle rocket and then like blow it up in midair or have it homing and have it look at. That's not really a particle, man. That's an entity that you just have a lot of. And so if you have a lot of entities that are like bullets or whatever, and you want to do fancy things with them, then yeah, then you're more in this like things world. But if you have more like smoke and dust and sparks, you're more in this world where really you ought to just break it all apart and SIMD it if you care. If not, just put them in things. It'll probably be okay. Again, if you have 30 if you have like 30 monsters and 1,000 particles, just shove them in here. You'll be fine. If you have 100,000 particles, probably better to move them out, put them on SIMD, put them on the GPU even better these days. That's what I'll say. The particles aren't things, maybe is a better way. As soon as things start, like things are stuff that you want to track, reference, serialize. Maybe you want to serialize particles. Anyway, that kind of thing. A little bit different.
You need to earn to be a thing. Okay? Like it's not like every little thing will be a thing, you know? You need to be a thing.
Got to be a thing. But again, going back, if you're making your first game, or if it's a small game, just make your particle things, and you'll probably be all right. That's what I think.
So I
know, maybe. Don't yell at me if you're nuts.
Nice. Is this the end then of the two-part segment, two-part
I think
series
we covered it.
of
I don't know. Do you feel like you can make a
things?
game? Can you make a game now? Are you ready? It's just
Is this
logic
the
from
next
here,
step?
right?
Is this the next step?
Oh, God.
Make a game on stream.
Yeah. Just take this and then just go for it.
All right. So this will be available for members immediately in this raw fashion. Maybe I will like do like a quick edit of like putting those two parts after the disconnect together. But generally, the edited version will go out in a couple of weeks because the editing takes a little bit of time, especially for the style of sessions. And then in the future, maybe we'll do something different, something new, something fresh. We'll see. Now, thanks a lot, Anton, for taking the time and effort to going through that in both parts. And
hope I don't get crucified on Twitter.
We can do a couple of like highlights, like your I don't know what was the most outrageous thing you said. Maybe they like iterators.
Maybe.
It's
all wrong. It's all wrong in one way or another.
It's like it needs to be sort of high level enough so that like everybody will have an opinion. This is it. Like then there's the controversy is like there, and yeah. All right. Thanks, Anton.
Thank you.
I will now. This will be the end of the video segment. We're still live. If there are people that want to ask random questions to Anton, you have like 3 minutes, and then I will shut off the stream. So there's like last call for questions to Anton. Now it can be like about everything. Open-ended questions about things. By the way, you mentioned a couple of times it's like the world is your oyster, but you also created a like Łukasz podcast local reference that like you are in your own cabin and you can do your own code styles, and you can do whatever you want because it's your cabin. So
Yes.
now we need to use that more. We need to be like, hey,
This is my cabin.
it's like, this is your cabin, so you can do whatever you want. Like, you want goblin
Yeah.
pool? Hey, it's your cabin, man.
No one's gonna come after you. Yeah. You gotta drop the feeling of like someone is gonna look at my code and be like, Goblin pool, what the hell? What does this guy think? Yeah. That's if you drop that, then you're free. You freed yourself.
Questions coming in. How can Anton work with sunlight on his face? That's the top. Actually, perfect question. Okay, how can you do that?
You need the vitamin D3, right, for sustained coding.
Only here on one part.
I don't know. I don't feel it. No, it does get hot sometimes, but I don't sit like, I think I probably adjust, but then I'll be off camera or something. I don't know. I don't notice it. I notice the cold if my fingers get cold.
But you get cold when you type?
No, that's why I got to keep typing. If I stop typing and I'm like in a meeting, then my fingers get cold.
Like, do you use autocomplete?
No.
Not at all?
No.
Wow. Like, is your like fingers like super muscly? Are your like fingers like, you know, like do you weight lift with just the fingers now? Because like you type so much that they're like
I do Kung Fu and I did climbing, so I have relatively strong fingers. But I got like some RSI from playing StarCraft, and so then I had to like get ergonomic equipment. But other than that, I haven't had any problems. I mean, I think in reality, there's not as much typing. Like maybe that's why I have like a relatively minimal style, because I don't want to type stood colon all the time and autocomplete. I'm like, no, I want most characters I type to like be pretty meaningful. And I think I think by typing it, you remember the code. And so it does become somewhat impractical in a large code base. But again, in your cabin, you kind of want to know where your stuff is. And so, you know, I think it's doable. But yeah, large corporate code bases that you didn't write, autocomplete starts to become really valuable. Again, I don't know what size that happens. Dreams was, I think, 300, 200,000, 400,000 lines. And we didn't use I didn't use autocomplete. So that was fine.
Oh, really?
Yeah. So something like that. I don't know. It was I think it was 250,000 when I was there. And so maybe it got bigger. Yeah.
That's when you have your lines meaningful. Like
yeah. Because you could do a big thing in like in 250K.
Yeah.
I mean, 250K is not a lot, but it's not a little, but it's like feels about right for
Damn. This is a revelation. Okay. New questions. What keyboard is Anton using?
Philco, Majestouch, Aqua.
Damn.
I don't know. It's nice. Philco. Buy it. I like cherry brown switches. That seems to be the mechanical keyboard helped my RSI. I tried like ergonomic keyboards and all this stuff, but like seems like I think it's because I was pressing too hard, and the subtle clickiness helps me not press too hard, and I think that saves my fingers.
Nice. Yeah. Do you use this keyboard in work?
I just buy them everywhere I go. I just buy them when at work, and I just put it there. I like fun fact.
When you leave the company, do you leave the keyboard?
If I buy it with their money, presumably.
Oh, okay. Okay.
But like the one at Media Molecule is mine. So like if you ever watch a Media Molecule stream where they have the intro and there's somebody typing on a keyboard, that's my keyboard.
Let's see. My colleague asked how much of the PS Move controller was designed by you. She mentioned multi-team effort.
So I designed the vision tracking part. So basically everything that tracks the glowing ball I designed. The core team on the software side was 3 people. So it was like Rick Marks leading the team. I was on vision and Eric Larson was on inertial fusion. So we kind of just divided it kind of Conway's Law style. It's like everything related to cameras is Anton, everything related to inertial sensors is Eric, and everything related to API and project like wrangling was Rick, and since he was the most senior and he had the most connections. And then on the hardware side, it was pretty much mirrored. Miyazaki-san in Japan was on the management and hardware structure side, and then Toshimasa Araki was on the mechanical engineering, and Kazuyoshi Enomoto was on the electrical engineering side. And I think there was more people added later, but that was sort of like 3 on hardware, 3 on software. And then later we added people for demos and so forth, and bulletproofing the SDK and all that stuff. But yeah. So I didn't, and then there was industrial design, one more person for the actual look of the controller originally, and then another person later on. And so, yeah, so I helped design the way it works and the vision part of it. Yeah. The vision stuff's actually pretty cool. Like, it might be interesting to talk about sometimes, because that algorithm is like kind of bonkers. It's like, because we had so few pixels and it's so far and the camera is like so old and all these things, and we had like 1 megabyte of memory. So it's like lots of funny tricks that are in there that completely are not applicable to anything. But you're just like, what
now it's like a relic, yeah, like a lesson in squeezing bits.
Yeah, it's like one of those like Apollo computers where you look at it and go, what is this thing? Like, you would never do it like this now. You'd use like machine learning this and, you know, AI that. And back then it was just like, no, we have 30 pixels. We will look at each pixel and look at the whatever and count this and that. It's wild.
So when you show the keyboard, Nuno typed no numpad, immediate loss of respect. Yeah. And then I ran a poll. Numpad sucks. Yes, no. and no option had 62 votes. I'm like,
for numpad?
Yeah.
Oh yeah.
I'm like no numpad.
Yeah, yeah. Well, this is modern. We're modern people. Nobody in the modern world uses. So I love numpads actually. And especially for like 3D modeling, they're good. And for just typing numbers and feeling like a boss, they're good. I used to work at like a reptile shop, and I worked the register sometimes, and you just feel awesome. Like, bam, 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 bam. They're great. But I got it because if I have it, my right arm has to go farther, and it starts to ache my shoulder. So it's mostly for ergonomic reasons. If it wasn't ergonomic reasons, I would have kept the numpad. I like it.
Does Anton know any tricks for removing ghost contact manifolds in your physics engine?
No, I don't know enough about physics. I know what contact manifolds are. I actually don't know what ghost contact manifolds are.
What is your physics engine?
Maybe they just mean it in one's physics engine.
Okay.
I think maybe they have ghost contact manifolds, and they need some exorcisms on the ghosts of the manifolds. There's some people. Yeah, there's a lot of good physics people out there.
Okay, there's one question, but it will like start another podcast, so I'm skipping this one. I'm sorry, Rayleigh. Stepping away from games, how would you handle fixed memory limits for other types of applications? Just fucking use them.
I mean, you know, it's a bit spicy to say fixed memory limits as well, because it's like, you know, the reality is that you don't always know at the beginning. But so the best way I would say it is kind of like what I was saying about the generation IDs. I think you just have to be really clear whether you don't know because you haven't thought about it, or you really don't know after thinking about it. And so for like the generation IDs, I would, you know, we talked about like, oh, it might blow the integer. And then I was like, well, let's run some numbers and be like, when does it blow the integer? Okay, in 400 years. Okay. Then it's kind of staring at you in the face. And what's staring back at you is like your own perfectionism in a way, where you're like, no, I want it to be perfect, right? And it's like, I think the same thing is with memory management, where really commonly you really could say that you're okay with like 40,000 things or whatever. So like, for example, for the calculator, the not calculator wrote, it's like, how big are these programs going to be? Are they going to be 4 gigabyte files? No, right? They're going to be, probably 600 lines at most or something. I don't know. So you can kind of put a number to it. And then on PCs, you can just, you actually could just virtual alloc a huge chunk, and just be like, okay, I'm going to take like 4 gigabytes, and you won't commit that stuff until you touch it. And so the behavior you get is that, you don't get out of memory errors. Well, how do I say it? Okay, working backwards. Let's say that you feel like, no, I really just don't know. It might be a gigabyte. It might be 60 gigabytes. Okay, take like 3 terabytes and virtual alloc 3 terabytes. Okay, well, because if it's more than that, you're probably writing a different application, right? But take some gigantic limit that you sure, like, first find the place where you're like, oh yeah, not more than that. All right, just set that, and then you'll say, well, it's just gonna, page fault or whatever. You say, okay, well, how do you think of it as like a caching problem instead of a size problem? You say, okay, what's the largest data set I'm gonna have on one screen? So like if it's a text editor or something, how many lines can I fit on a screen? Well, even if each character is 1 pixel, it's no more than like 4K or something, right? So it's no more than 4K lines. So you can kind of do these things and say, okay, I'm going to have like max 8K lines on the screen, and then start thinking of it as a caching question of how do I get my data into that cache? And so maybe the problem of how to fill that cache from an unbounded amount is a thing, but everything after that can be fixed size again, if that makes sense. So maybe your like core editor logic says, okay, I'm never going to have more than 16K lines that I care about. But you want to handle, large terabyte files, and then you do a separate problem, which is like, okay, how do I memory map the disk and get those things into that cache? And then so like, it's really just, can you find a place that's fixed, and then maybe move the logic of how to get stuff into it away from that. So that way your core logic, like within your text editor, you're not doing like add a character, oh, and that may resize my whole text buffer or something to 8 gigabytes. Like that's not helpful in my experience. So thinking of it in terms of kind of cached small areas that maybe need to be filled in advanced ways. So again, like an example for Modeler, it's a 3D modeling software, professional grade. You're in practice not going to have more than 1 million entities. You're going to choke on other things before then, right? Probably rendering, probably other things. So it's perfectly fine to just virtual alloc 1 million spaces. You're also probably not going to page fault because the memory is pretty cheap, size-wise. So it'd be like couple of 100 megabytes if you had 1 million things. So you're probably not going to run out of memory. And then from there on, you just don't have to think about that anymore. So that's how I would do it. I don't know. You just have to think about it, I guess, and consider it. All I'd say is like, just consider what happens and put some hard numbers on it, and maybe try to get away from the feeling of perfectionism or something. I don't know.
It's like, it really depends also on the actual application that you're making. Like, especially I keep having this like split in my brain whenever we're doing podcasts or discussions about programming. It's like desktop software, or like software that will run on a platform that you know or maybe control, versus like server software in a like web application fashion with like containers. Like, two different worlds, two different worlds of thinking about these problems. And it really depends on like, do you know the specs that you're gonna work on? Like, what is this? Like, is this a desktop app that's supposed to be working across platform?
Yeah.
Or like on a like specific OS? Or maybe a hardware that you control it's like a console fashion, or you're selling hardware with software. Like, it all impacts the decision of like, how do you want to do it?
Yeah, and I guess all I would say is that you're gonna have to make the decision somewhere anyway, because I think, well, all I'm trying to say is that it's a mirage to say that, oh, just because I put stud vector in there, now I'm like scalable. Like that's not really the truth. The truth is more like, well, if you run out of memory, you can now have exceptions everywhere or crashes or whatever. So if someone writes like super duper careful exception handling code for all their stud vectors, okay, maybe that's not my preferred style, but at least like that person is really like putting their money where their mouth is. But if I just see a bunch of stud vectors strewn around the app and people are like, oh, it's dynamic, I'm like, well, it's not really. It's going to crash like when you hit these limits. Like I might have as well, virtual alloc a huge array, and they'll say, well, that might page fault. Like, yeah, so will the stud vector. Like either you handle it or you don't handle it. And so if you're not going to go full hog and like have exception handling everywhere and out of memory handling everywhere, well, like you have to compare that program to one where you have a fixed limit, because the fixed limit solves that problem. It's just say, look, I could either decide I'm going to deal with like 100,000 things, or I got to handle every single out of memory error / exception condition. Those are the actual two kind of like faithful, true, honest positions. Everything else is sacrificing something somewhere. Like the hack of like, oh, I'm just going to commit 6 terabytes. Yeah, it might page fault. But also using stud vector everywhere also might crash, right? So if we're talking about like a server that's going to Mars or whatever, what are you going to put on that thing? Like if you really want to do it right, so to speak, you got to pick a strategy. And I feel like saying, okay, the strategy is going to be that I'm going to have a fixed buffer and I'm going to manage that buffer, puts you in the mindset of like, I'm dealing with this. And then you're like, this is annoying to deal with. Okay, how can I deal with this in the smallest possible place? Oh, I'll allocate in one place and deal with it there. Or I'll make a cache and deal with it only when I put things in and out of the cache, and now it's abstracted. Everybody else can kind of deal with the fixed things. So it's like, holistically, how do you actually solve the thing, rather than like, otherwise we're just arguing, how do I pretend to solve it? How do you pretend to solve it? Like so thinking about it as like something you'd put on a Mars rover that can never be maintained, compare those two pieces, and then, yeah.
All right. Thank you, everybody who joined in and stayed with us until this moment. Tomorrow, similar time, Alex Evans is joining me, and we're gonna first design the hardware from scratch, and then in the next episode do the software for it, programming in C. So that's gonna be super awesome.
I want to see that.
Somewhere in the future, actually in 2 weeks, there's gonna be 100th episode of this podcast, and there's gonna be interview with me, Ben Wisnes from Handmade Network, will be grilling me with questions, and my wife told me that she will tell everybody from our friends circle to come and ask like the questions that they can now use this opportunity to smuggle in questions. So this will be live streamed, so I will have a limited ability to avoid the questions. So
oh no.
And there are a couple of things that they already said they're gonna ask, and we'll see what happens. So thank you, everyone. See you tomorrow? Question mark?
Yeah, I want to see that.
Perfect. Bye bye, everyone.